Hi, Algebra 2 students. These notes are on inverses. So we're going to just kind of review our definition of an inverse and then get into some examples of how we can find a function. Given a function, how do we find the inverse of that function? Okay, so first of all, just like a little bit more on what is an inverse. So if we have some function f, and say f is a mapping that takes us from a set x to a set y. So this is a more abstract definition, a more formal definition of a function where we think of it as a mapping, not necessarily always an equation. So say I have some like numbers in my set x and just kind of randomly picking some numbers, and 1, 3, 7, and -5, and then also going to kind of randomly pick some numbers in my set y. Then I kind of have this mapping of f, and f is going from x to y. So this would be our input, and this would be our output. And so we can imagine it's mapping an x value to a specific y value, or to a specific f of x value. Okay? Well, what is the inverse? The inverse is going to go in the opposite direction. So it's going to take us from the set of outputs back to the set of inputs. And we're calling that f inverse. So I would read this as f inverse, not f to the -1. I say just f inverse. And now my inputs are in the set y, and my outputs are in the set x. So if I can kind of imagine all of my arrows getting switched and going in the opposite direction. So that's kind of like a visual understanding of an inverse. So then let's just kind of formalize that a little bit more with some words. So we say f of x and f inverse of x. That's a -1. Not sure if you can tell. Are inverses of one another if, when you compose them together, f composed with f inverse of x is equal to the other order of the composition, f inverse composed with f of x, and both of those are equal to x. So if you relate this idea back to our picture, the idea would be that if I do both functions in order, so if I first start with an input, say 1, and I apply the function f to it, it maps it to 0. But if I then compose that with f prime, now f prime is taking 0 and mapping it back to 1. So I get back to where I started. So that's this idea of us getting back to our original x value, is that we get mapped to an output, and then the output gets mapped back to the input. Okay, so let's look at a couple examples. Our first example is going to be a table of values. So I'm going to say this is x and y, and I'll put in a couple of values. So 0, 1, 2, 3, 4, 6, 4, 2, 0, -2. So I'm following a pattern here. This is like subtract 2 pattern, right? So this is what I'm calling my function f. So then these are all of my kind of f of x values. The y values are the same as f of x. Okay, so y, I'm just kind of like putting this notation here. Y is equal to f of x. So then if I want to say what is the f inverse function, well, now basically what's going to happen is my inputs, my x values here, should be the y values from over here. So I would just switch them. So I would say 6 is now an input that goes with an output of 0. 4 is now an input that goes with an output of 1. 2 is an input that goes with 2. 0 goes with 3. And -2 goes with 4. And we've just kind of created a simple table that is f inverse to this f. So if I was to compose them together, say for like f composed with f inverse of 1, I would do 1 gets mapped to 4, then I come over here and 4 gets mapped back to 1, and I'm back where I started. So that's a pretty basic example with just switching the x and y values. But we're going to see that that's exactly, we're going to kind of do the same thing if I ask you to find an inverse of a specific equation. So if I say f of x equals 3x minus 5, and I say find f inverse, well, what we're going to do is, first of all, we're going to rewrite this so that I'm going to get rid of my function notation. I'm going to replace the function notation with a y. Okay, I'm going to write some steps. So we're going to kind of like replace f of x with y. There's not a really strong reason why, but it kind of makes things a little bit simpler for us in terms of our understanding. So these are equivalent, essentially. I just replaced f of x with y. And now this is still f, right? But what I'm going to do next is going to change it. I'm going to switch the location of the x and the y. So I'm switching x and y variables within the equation. So what does that look like? That means this is now, I'm going to write it in different color. This y, this y becomes an x. The 3 stays the same, but that x becomes a y minus 5. So ignore my little scratch out up front. Ignore that. Okay, so now that I've switched them, essentially just by switching them, this is now f inverse, okay? So this function here is f inverse essentially, but it's not in the nicest form because I typically would like to say have y by itself, not have x by itself. So then our next step is going to be to solve for y, which means isolate y, get y by itself. So how do I do that? That's not too bad. I have to add 5 to both sides. So then I have x plus 5 is equal to 3y, and then I would divide by 3. And I would get y is equal to x plus 5 over 3. So this right here, this is f inverse of x. Because I switched my x and y values, I switched my input and my output, and then I solved for y, so now this new y is essentially like the x was in the original up there. Okay? And in order to check, we can actually do the compositions, right? So if I wanted to check my work, I would have to do f composed with f inverse of x and see what I get. So when I do that, that means f of x plus 5 over 3. That's my f inverse function. I'm plugging it in for my x values in x. So then that means I have to do 3, and then where this x was, I'm going to put the x plus 5 over 3. So that's replacing x in f of x. And then I would do just minus 5. So like what am my goal is, I know that we did this correctly if this will simplify to be just x. So let's see what happens. There's a 3 outside and there's a 3 in the denominator. What do you know? Those will cancel. So then I would get x plus 5 from inside, from the top there, minus 5. Well, what's plus 5 minus 5? That's just x. So that way checks out. And then I would also have to do the composition the other way just to make sure it works both ways. It's commutative. And here, I would get f inverse of f. So f was 3x minus 5. So that means I'm plugging in 3x minus 5 in for the x in f inverse. So it would become 3x minus 5 plus 5, from this plus 5 there, divided by 3. So we're seeing I'm just kind of using that same structure. Okay, so what happens here? Minus 5 plus 5 will cancel. And I get 3x over 3. Then the 3's cancel. So I get x, and this checks out. Okay, so at the bottom, I'm just going to put one u-try problem. So my u-try problem is going to be f of x is equal to negative 5x plus 8. And I'd like you to find f inverse of x and check your answer. So to check, that's where you're going to do the composition. Okay? And we're definitely going to be practicing this on Tuesday of next week.